Hello everyone, and welcome to this first video for Unit 2 where we're going to learn about the structure of an atom. But before we learn about the structure of the atom, we have to learn about the history of the development of the atom. And so let's go ahead and get started in that. We're going to learn that matter is anything that has mass and takes up space. And so we're also going to learn that all matter is made up of atoms. And we're going to talk about how atoms were discovered in the history of that. So we're going to talk about several scientists and philosophers who kind of came up with this atomic theory. But just know that we're not covering all of them. There's a lot of people who contributed that we won't mention. But we're going to talk about some key discoveries that show us how atoms are structured. So the first scientist we're going to talk about is Democritus. And so Democritus is a Greek philosopher who existed 400 BCE, around that time, and so that was about 2,400 years ago. And he had this thought experiment where he said, if you were to take something and divide it a whole bunch of times, would you get to the point where you can't divide it anymore? And so let's go ahead and think about this piece of silver here. This is a silver American Eagle. It's 99.99% silver, and so we're just going to assume it's 100% silver. And so he had the idea where if you took this and you were to divide it in half, and you continually divided it in half, would you get to a point where it's no longer silver? And so again, let's think about if we infinitely divided it in half, is there a point where we can't divide it in half anymore? And the answer actually is yes. There is a point where you can't divide it anymore, and that is called the atom. And the word atom actually means indivisible. That's where that word came from. And so, again, this was first proposed 2,400 years ago. Now, the next person we're going to talk about, and this is a picture of kind of the idea that you have this particle you can't divide anymore. But the next scientist we're going to talk about is Dalton, John Dalton. And so John Dalton came along, and this was in the early 1800s, and he said, he expanded on this idea of the atom. And so there's 4 statements that he made that really, solidified our understanding of the atom. And so let's go and talk about those 4 statements. Now, what I'm going to say is 2 of those statements are actually incorrect. But even though 2 of them are incorrect, it's still pretty good that he was able to come up with these ideas considering that there was not a lot known about the atom. So let's go ahead and talk about the 4 things. The first thing he said, or the first thing we're talking about, is that all substances are composed of tiny, indivisible particles called atoms. Now, I just said that there is a point in which if we infinitely divide this, there's a point in which we can't divide it, but what it is there's a point where we can't divide it again and it still be silver. So we have actually learned that you can divide an atom, and so what's wrong about this statement is that atoms are divisible, and you can divide them into subatomic particles, and we're going to talk about that later. So this statement's not correct because we later on discovered that you can divide atoms. It's just that when you do that, they're no longer the element that they were before. The next statement is he said that atoms of the same element are identical, and the atoms of one element are different from those of another. And so this statement is pretty close to true, but it's also false. And so if we were to think about this silver, all of the atoms in this silver, are all the atoms of silver the same? And we're going to learn later that there are small differences, and we'll talk about that later. So they're not identical because there are differences, so that is not correct as well, and we'll talk about that later. The next statement, he said atoms of different elements can physically mix together or chemically combine in whole number ratios to form compounds. And so this is true because think about what water is. Water is H2O. That's 2 hydrogens, 1 oxygen. And so atoms can combine in whole number ratios to form compounds. And in this situation, it's a 2-to-1 ratio of 2 hydrogens to 1 oxygen. Another example would be carbon dioxide. There's 1 carbon to 2 oxygen, so that's a 1-to-2 ratio. And so this is something that he observed. The next thing is that chemical reactions, or when chemical reactions occur when atoms are separated from each other, rearranged, and then they come back together and form different bonds. And so atoms of one element, during a chemical reaction, atoms of one element will never change into another element. And so essentially what this is saying is if we start with carbon and oxygen, for example, and a chemical reaction occurs, we're going to end with carbon and oxygen. And so those atoms can't become a different element in a chemical reaction. And so we're going to learn about that later when we learn about chemical reactions. So those 4 statements, 2 of them were false and 2 of them were true. However, again, that's pretty good considering that we, as humans, didn't know anything back then. So scientist number 3, we have J.J. Thompson, which is Joseph John Thompson. And so he actually, in the late 1800s, discovered that atoms could actually be subdivided. And so he actually discovered that the atom contains a negative charge, which we later on discovered is the electron. So essentially he discovered the electron. And by doing this is how we know that Dalton's first postulate was incorrect. He said that atoms could not be divided, but they actually can be divided because of the existence of the electron. And so Thompson concluded from his experiments with cathode ray tubes that atoms actually contain a negative charged particle, which we will talk about later on as the electron. And so this is what his cathode ray tube looks like, and he was able to discover that there's a negative component to atoms. And so he came up with this idea, this theory called this model called the plum pudding model. The other thing it was the other name for the model is the chocolate chip cookie model. And essentially what he envisioned is that the atom is a positive sphere, and within the positive sphere you have a bunch of negatively charged particles, which we are going to call electrons. So that was his model there. All right, scientist number 4, Ernest Rutherford, and look at that mustache. And so he discovered, using the gold foil experiment, that atoms actually contain a nucleus. And so in 1911, he expanded on our understanding. In his famous experiment, the gold foil experiment, Rutherford concluded that atoms consist of a very small, positively charged region that he called the nucleus. And so what he discovered is, instead of J.J. Thomson's model where the whole atom is a sphere of positiveness, what he discovered is that, well, all the positive is actually in the center of the atom, and he called it the nucleus. And he said that the negative charges, which are the electrons, surround the nucleus. And so this is what his gold foil experiment was. He had this gold foil that was very thin, and he shot these alpha particles at the foil. Now, we haven't talked about what alpha particles are, so you don't need to worry about them. But if Thomson's theory was correct, the alpha particles would go straight through the gold foil. However, what he noticed is that most of them went through, but some of them either bounced back or they ricocheted off to the side. And so most of the alpha particles went straight through, but some of them did bounce off and go back. And so this is another picture of that, so you can see that most of them went through, but occasionally some of them would bounce off or bounce back. And so if you take a look at this picture here, you can see how most alpha particles will go through because the atom is actually mostly empty space. However, there is a very, very small, very dense nucleus that occasionally an alpha particle would collide with. And if it collided with that nucleus, it would ricochet back. Now, what I want to point out is, look at the very top line. Look at the very top line. Notice how the trajectory is going straight, but then it bends down without even touching the nucleus. And we'll talk about this later, but the reason why it did that is because alpha particles are positive, the nucleus is also positive, and if you have a positive and a positive, they repel each other. And so that's how he was able to conclude that the nucleus was a positively charged region. So this is what he discovered. He said there's a nucleus, and that the atom is mostly empty space, and the electrons are going around the atom. So just a quick thought. All matter is made of matter, or made of atoms. So that means you are made of atoms, because you are made of matter. And if atoms are mostly empty space, then that means you're mostly empty space. So it's just a weird thought to think about. All right, next scientist, Niels Bohr. And so Niels Bohr more accurately described what the electrons are doing around the nucleus. And so what he said is that electrons actually exist in very specific orbitals around the nucleus. And so if you take a look at this model here, you'll see that the electrons orbit the nucleus, but they're orbiting in a very specific orbital. And so they'll either be on that first energy level or that second one or a third one, but they won't be in between. And so it's very specific where they are around the nucleus. So it's very important what he discovered there. And so Niels Bohr's model, he came up with a Bohr model of the atom was developed in relation with the study of hydrogen emissions, which we'll actually talk about in Unit 3. We'll talk about the emission spectrum, but he used emission spectrum to come to this conclusion. Again, we'll talk about that when we get to Unit 3. So these other scientists, what I will say is these other scientists made very huge contributions in terms of how electrons orbit the nucleus as well. These particular scientists, though, we won't really touch on too much of this unit, but we will next unit. But let's talk about some of the things that they discovered. So, several scientists, including de Broglie, Heisenberg, and Schrödinger, contributed to our understanding of the structure of the atoms, particularly with orbitals and how electrons orbit around the nucleus. And so what I'm going to do is show you a picture here of how we understand orbitals now. If you take a look, these are actually the orbitals that we will learn that these scientists developed or came up with in terms of how the electron orbits the atom. However, this is something that, again, we're going to cover in Unit 3, so you don't need to understand this right now. So let's go ahead and do a quick summary. We have Democritus, who came with the idea that if you continually divide something in half, you'll get to a point where you can't divide it anymore, and he came up with the term atom. Dalton came up with his 4 postulates. 2 of them are incorrect. One of them was that atoms are indivisible, which we learned that they are divisible when Thompson discovered the electron. And the second incorrect thing is that all atoms are identical, which we will learn why that's false in a future video. J.J. Thompson discovered that the atom contains negative particles that we call electrons. Rutherford discovered the nucleus and that the atom is mostly empty space. He discovered this with his gold foil experiment. Niels Bohr discovered that, more accurately described how electrons orbit around the nucleus. And then those last 3 individuals, you won't really need to know that for this unit. We will talk more about them in Unit 3. So you can just keep that on the back burner for now. And that's it. So that's all the history we're ever going to learn in this class, thank goodness. But these are very important figures in the development of the atom. And like I said in the beginning of the video, it's not including everyone, but these are very important discoveries that allow us to understand how atoms work. All right? Well, you guys have a great day and take care.